So, everyone ready? So, I've been asked by David Woessner to kind of keep the bio short today. So, but I will say a couple things. So, first of all, I'm Sanjay Raman. I'm the Associate VP for the National Capital Region, and I'm the organizer of this Science and Technology Innovation Policy lecture series that we have here in our National Capital Region campus. And I appreciate everyone coming. We've got, I think, a few people at least on streaming link as well. Local Motors is a very, very interesting company. You're going to hear more about it from David as the course of the discussion goes on. I first learned about them when I was at DARPA under a program called Adaptive Vehicle Make, which was a pretty forward-looking program that was looking at essentially digitally manufacturing vehicles for the Department of Defense and using crowdsourcing techniques to try to get those designs considered and enabled. So I'm not sure. I think Local Motors has been around for a while before that, but I think that was certainly a big event in the history of the company, and I think it's really grown in some really interesting directions since then. So I don't want to spend too much more time stealing your thunder here, but I'm really excited to have David here. Among other things, David is the graduate of a fine institution, Georgia Institute of Technology. He and I share that heritage. I think he graduated slightly after I did, a few years after I did. So I really want to express my appreciation, David, for you coming over, and we're looking forward to the discussion. I will remind everyone, if you want to ask a question, please just press the red. There's a vertical button, and your mic will turn red. And when either during the course of the discussion, if you're okay with it, or at the end, we'll do some Q&A. And then after the talk, we'll step out to the reception and continue the discussion after that. So, David, thanks again for coming, and we look forward to the discussion.
All right. Thank you, Sanjay. Good afternoon, everyone. Appreciate to be here. So I feel like I'm at a lecture. I might actually use the whiteboard. But first round of extra credit, the closer you are, the more engaged we can be. I know this is one thing as a professor, you always struggle, like everybody wants to sit in the back, come up front. It's okay. We can have an intimate conversation. You don't have to be scared of me. So as Sanjay said, my name is David Woessner, spelled David, but pronounced David. We have two things in common, actually. I have responsibility for Detroit and the Midwest, as well as D.C. and the Mid-Atlantic. So we've done a good amount of work in near Ann Arbor and the Southeast Michigan area. And then I do have the other additional pleasure and honor of being a graduate of that other tech school in the ACC. I think our football record this year is 1-0 against our ACC tech rival, and 1-0 against our other rival, which is the University of Georgia. So I think we've had a good year with that. Other than that, I won't mention Georgia Tech anymore. But how many of you had heard of Local Motors before today? Okay, so good amount of room. How many of you have an account with Local Motors? We got to work on that. All right. So I want to start a little provocatively before I go into my talk and show you a video. And this worked in practice, so hopefully it'll work in testing.
This is the end. The end of the assembly line. The end of the showroom floor. The end of the smooth-talking salesman. The hard sell. The soft sell. The oversized inflatable gorillas. And overinflated inventory that absolutely must go. This is the end of the junkyard full of old cars, leaching chemicals into the ground. Born from the concept of cradle-to-cradle manufacturing. Printed in front of you to be the exact car you want. Melted, deconstructed, and rebuilt to be the next car you need. This is where vehicle manufacturing as we know it comes to an end. and where vehicle manufacturing, as it should be, begins.
So that is our concept of what vehicle manufacturing and technology integration will look like in the future. We are Local Motors. We design, build, and sell vehicles at local microfactories. And our name doesn't say it all, but it suggests that we focus on cars, but we actually talk about Local Motors being more of the local engine of an economy, right, to create high paying advanced manufacturing jobs, locally enabling local supply chains. And we exist not just because of that, but because we really fundamentally hope to shape the future. And so we say that humbly, but we also say it meaningfully because we want to create a better world through hardware, right? So our vision is to create technology-forward products that inspire, empower, and nurture humanity. And this is why I asked how many of you had heard of Local Motors, and I think 4 or 5 hands went up. But out of those 4 or 5 hands that went up, what I encourage everyone to do, and I encourage you to encourage your students to do, and anybody watching online, you guys can Google now and look up launchforth.io, which is our platform, and I'll talk about that a little more. But just like you have a Facebook account or if you have a Twitter account, we encourage you to join our community of co-creators to go and collaborate with us as we develop these vehicles and products of the future. So that's my one pitch. Come on in, sit up front. Don't be shy. All right, that's okay. So why did we tackle the biggest system of them all, right? Car manufacturing has pretty much been the same for the last 100 years, since Henry Ford invented the assembly line in the early 1900s. Well, we think the vehicle system is probably the most system in the world and some of the biggest, right? So when you think about vehicle design, vehicle development, vehicle engineering, vehicle testing, production, marketing, financing, service, it gets pretty challenging, complex. And so we thought that if we can tackle this humongous system that's really complex and spans the globe, we can pretty much tackle any other system after that as well. The other reason why we tackled that, because it's pretty lucrative industry to enter. And if you can figure out how to knock down some of the barriers of entry that have existed over the last 100 years, you can probably get a piece of an industry that some people value at $2 trillion, right? We are getting on to a path of 100 million vehicles produced annually around the globe at an average transaction price of $20,000. That gives you $2 trillion of an industry. If you take Adam Jonas's model from Morgan Stanley, who talks about there's really 10 trillion miles driven of all the vehicles a year in the world, and you value a mile driven at $1, you get to a $10 trillion industry, right? And because that's as we move to mobility as a service, that's probably a better measurement, miles traveled versus transaction prices of vehicles built. And then you can add on to the periphery the significant amount of services that are associated with the industry, and people have valued that at potentially another $10 trillion. So you have this $2 to $20 trillion industry that automotive, represents. And so I think it's an attractive industry to get into, to disrupt, because there's potentially a big piece of the pie that you can capture. But the genesis of Local Motors started a little different. It started when our founder and CEO, Jay Rogers, was fighting in Iraq in 2002 and 2003 and 2004. And he realized we were fighting a war over resources, right? Over our foreign dependence on oil. And he said, well, if we're fighting a war over resources, and we're using vehicles, and that's what happened to him while he was deployed, is his unit got attacked and 2 of his buddies got killed because the vehicle they were driving and operating in was fundamentally not fit for purpose, right? It was developed in the 70s and 80s, and deployed in the early 2000s. So he said, what do I need to create more safe vehicles that are fit for mission? The other way to look about it is, he talked about it from a military perspective, but this is a picture he took in 2015. And this is a family of 5 driving in India on a Hero motorcycle. And this is another aspect of really vehicle safety and not being fit for purpose, right? This is potentially an affordable option for this family, but it's certainly not a safe option. So Jay wanted to address the issues of safety and fit for purpose for local requirements and markets, and the dependence on foreign oil. So he certainly didn't necessarily do that in our first vehicle, which I'll talk about, which was a 430 horsepower V8 6.2 liter street legal desert racer. But in our transition over the last several years, we're focused on low speed electric vehicles. So the model was brought out of the necessity of how do we conserve resources and how do we provide vehicles that are safe to meet local transportation requirements. And so we had this thought that we as vehicle manufacturers have an obligation to be great and to do what our mission is, which is to create better products through hardware and change the world through hardware, but also to create safe, smart, and sustainable products that leave a smaller footprint and meet the mission that they're built for, right? So when you think about a complex system and some of these other challenges, we set out to fix the complexity. So this is the interactive part of this conversation and lecture. How many of you still drive cars or vehicles? All right, pretty much all of you, about 2/3. So we have some metro riders and some bus riders, so that's fantastic. How many components on the average vehicle? This is the interactive part, remember?
15 a lot.
All right, 15,000? 10,000? A lot? That's pretty. He's clearly in operations. Any other guesses, estimates? It's ballpark 20 to 25,000 components in the average vehicle. If you have a gas-powered vehicle, right, an internal combustion engine vehicle, around 8,000 components are just in the powertrain. So when you think about complexity of the system of what I described earlier, to create a value chain and a supply chain to meet those components, that gets pretty complex and expansive. This is a blowout of the Strati, the world's first 3D printed car. How many components do you think there are here? 5,000, okay? Any other estimates? 100, much better. Both of you still in the Price is Right would have went over, so neither one of you I can give your gift to, but it's around 50. So we have around 50 components. Everything you see in black that's not kind of blown up is actually 3D printed. So in this case, the tire, the steering wheel, the seats, the glass, that's not 3D printed, but the unibody is carbon fiber reinforced ABS plastic. And so when you fix that complexity going from 25,000 component to 50, you can really create a local supply chain again. Yes?
So does your 50 number include the powertrain?
Our 50, it actually does, because we have electric, right? And so when you think about electric, you got a motor, inverter, and a battery, and that's pretty much it. Now, granted, if you consider the fact that the battery consists of cells and, the entire module, then you could get to a higher number. But if you look at the battery in itself as a system, an integrated system as one, then you get to a lower number, right? So this is a battery electric vehicle. Any other questions, comments? So now, that was kind of the setup of the context of why we exist, right? And here's what we decided to do about fixing the complexity, right? We went back to the drawing board, and fundamentally we believe in a platform of co-creation and micro-manufacturing. Co-creation is the ability to harness the power of the crowd to design and develop vehicles. So rather than us believing that we have to have the smartest engineers, designers, and makers working for us, we believe in the philosophy that a lot of the smartest people actually don't work for us. And so we want to harness that power. So this is actually a collage of the Rally Fighter, which has pictures of all the people that participated in that vehicle challenge. So the Rally Fighter actually owns a Guinness Book of World Records as the world's first co-created or crowdsourced vehicle. So all of these pictures are the people that contributed to the creation of the Rally Fighter. So there's some cool videos out there if you'd like to look at them that talks about how it's maybe a Frankenstein of a car, right? It has a Chevy motor, it has a Ford transmission, and it has Civic taillights. But the purpose isn't necessarily to go reinvent the wheel. The purpose is to use the best out of existing pieces and the latest, greatest technology and integrate it as rapidly as possible to create a vehicle that meets local requirements. This, in this case, is a built in Phoenix, where a lot of people do off-road racing. Granted, this is also a niche vehicle that targets what I would call people with high disposable incomes, because it starts at around $100,000. The most expensive one we ever made was around $275,000, and it had a 720 horsepower supercharged engine in it and went 0 to 60 in around 3.2 seconds. Right? It's actually placed in the Baja 1000 in its class, so you can actually race it in the desert and then still take it to work or grocery shopping. So it's a unique thing. Every now and then we still have some at our facility in National Harbor. So if you come by, you might get a surprise and get a ride and drive in one. But that's our platform of co-creation, right? And so each one of our vehicles normally has a designer or a lead engineer that's associated with it, right? So we have, and they're from all over the world. Edgar Sarmiento is one of the most recent ones. And these are all success stories in their own right. The way we remunerate our community members, and we have around 50,000 community members in 140 countries around the world, is through two ways. One, through challenges, and if they win a challenge, first, second, or third place, they get a check for that amount of prize money that's out there in the challenge. And then on top of that, if we go and commercialize that vehicle, they get a royalty on each one sold. So off the top of the revenue number for each unit sold. And then the second one is if they contribute, because oftentimes we put project needs out there on our platform, and if they contribute significant pieces of, make significant contributions to the development of a vehicle, they get remunerated on a royalty based on that contribution on each vehicle sold as well. And so that's the interesting thing, and this is why I encourage students to participate, right? Because one, it gets them feedback on their ideas and their designs and their engineering thoughts. Two, it gets them recognition from their peers and from industry leaders. A number of our participants have actually gotten jobs because they were doing this as a passion project. Three, it gets them potentially some significant money, and it builds out their portfolio. And so Edgar is an industrial design student from Columbia who's studying in Italy. And when he won the challenge, he got a challenge reward for winning the challenge in 2015. And in 2016, when we launched Ollie in National Harbor, Maryland, he got a check for $20,000 more dollars. And so the next Ollie we make and we sell, he'll get a check off of that. We won't make a big deal out of each one, but you get the point. Right? And so this is how we approach co-creation. Any questions about that? Why are not more people on their iPhones or their iPads right now signing up, contribute? Yeah, there we go. Excellent, Steve. Appreciate that. Yes, ma'am. So that people can hear you online.
It sounds like you've really sort of modeled this after open source communities,
right?
But attached sort of remuneration to it. So I'm just interested in a little bit about your thinking and the history of that.
Yeah, so a couple things. What, Android and Linux were the open source software. We want to become the open source hardware. Now, that doesn't mean we don't believe in IP. We just believe in the original intent of IP wasn't to go sue the hell out of somebody to go, prevent them from doing things. The purpose of IP is to disclose, right? So we have agreements with each one of as part of the challenges, we have actual terms and conditions, right? And if you submit a design, at the end of the day, in order for it to for you to win the challenge, you have to. It's basically governed by Creative Commons, and so in order for you to accept the award, you actually have to have an IP agreement with us that also details out the royalties, right? And so the point is to disclose. It's actually really interesting when you think about competitions, right? You would think that people hold their ideas and contributions close to the vest, and you get a whole bunch of submissions at like 11:59 the night of the challenge. But actually what happens is a lot of people contribute very early on. One, because they want to get that attribution as the first to disclose. Two, because they want feedback from the rest of the community on the design or their project idea. And then they reiterate. So our purpose, both with the challenges, is to kind of do co-opetition, right? So people collaborate. Some people form partnerships as part of a challenge. Other people actually start off individual submissions, and then because they may partner with a couple of people, actually at the end have multiple people in one particular submission. So you see all kinds of competition, collaboration, and I think that's what we want to foster through our community and to enable so that you get a lot of minds on one idea or one project, but to bring different perspectives from it. And that's why you see in our communities, you see industrial engineers, industrial designers, mechanical, electrical, just vehicle enthusiasts, consumers, and makers to contribute to that. And so that's kind of the way we start. And the other piece that we want to encourage from a disclosure perspective, and this is also for us internally, is we want to be able to put out there things so that if they're not a success, right, we want to fail fast to be able to succeed faster down the line because of the iterations. So that's a big component of our development and design approach, both internally and then with our community. And more from our vehicle development. Right now, if you follow us, Steve, so you should see this, right? We had a vehicle challenge for drones with Airbus Cargo Drone Challenge. And more of that discussion that used to be internally between even our development teams, we're pushing onto our platform to have in a very open dialogue with the community to engage them and get that feedback. I hope that answers. Oh, okay. Because you were looking a little like, I'm not good. So that's the co-creation part of the platform. And then the second part is micro-manufacturing, which is really believing we're here to think big, but not to feel big. And we believe that big things like a complex system like a vehicle can come from small footprints. And the other belief why we focus on micro-manufacturing is because we don't just want to innovate, right? We don't just want to be the next app company. We believe that in order to differentiate ourselves and really make an impact on the world, we also want to manufacture, right? And we don't want to make just one of things, but we're also not going to be a mass manufacturer like a Ford or a GM and make hundreds of thousands of things. We actually believe that in economies of scope versus economies of scale, right? So in a small footprint, each one of our microfactories is about 50,000 square feet on 10 acres, versus if you look at traditional automotive factories, you're looking at 1 to 2 to 3 to 4 million square feet on 1 to 2 to 2,500 acres, making anywhere from 100,000 to 500,000 vehicles a year. Hell, if you go to Ulsan City in Ulsan, South Korea, you have a vehicle manufacturing facility that spits out, I think, 2.2 million vehicles a year. Right? We're never going to be that. What we think we can have in each one of our facilities, we want to focus on 1 to 10,000 units of a particular product. And so that's what, for example, our direct digital microfactory in Knoxville, Tennessee looks like. 50,000 square feet, 10 acres, right adjacent to the Oak Ridge National Labs manufacturing demonstration facility. And within 200 miles, about 22 million people live. You got Atlanta, Nashville, Charlotte, and Louisville, all within 200 miles of this area. And the reason why we picked Knoxville for one of our first ones because of our close collaboration with the Manufacturing USA Institute of Advanced Carbon Composite Material Innovation at University of Tennessee and Oak Ridge National Lab. Also Michigan State and Purdue are involved in that. And so we focus a lot on materials development and materials application, primarily around polymers for additive and subtractive manufacturing. And that's actually one of our, basically it's the second generation of the Strati, almost a 2.5 generation of the Strati. And so that's the vehicle, one of the vehicles we're manufacturing down there and producing down there. Grand opening is early 2017. The other, and this is a rally fighter, and this was our first, our first development vehicle. And the point is to get much more connected from a direct digital manufacturing perspective, right? So what is the fastest way we can go from digital file and digital testing to production? And then we also worked with the Rally Fighter on a number of things of being a connected vehicle, right? And so this was our first foray really into true connectivity and direct digital manufacturing. And the thing that the co-creation and micro-manufacturing process produced is the dark blue line represent 3 other vehicle manufacturers that I don't like to list on paper, but they are Tesla, Fisker, and Chevy. I won't give out which particular order, but the point is we are much faster to market, right? And this is to get to our 25th unit of production, right? Not our first unit of production, but the 25th unit of production. We're much faster, much less capital, but we use a lot more minds, right? Rather than just our own internal engineering team, we use the world to help design and develop this vehicle. The next vehicle set that go ahead, yes, sir.
So, do you think is there a correlation that you can attribute to the number of people involved in the design process and the time to market, or is the time to market just a function of the 3D printing and the supply chain?
It's a mix. Yeah. I think it's a mix. I think we push development because we do it in such an open... There's 3 components, I think, fairly. One, we have a much more flexible product development process and commercialization process than I think traditional OEMs. 2, we have a focus on getting the best minds in the world to iterate on vehicles quickly. And 3, we are okay with more of a software approach to product launches versus a traditional OEM approach. So our point is, how can we get an MVP, a minimal viable product, into the hands of consumers to go and then provide feedback and to understand if there's demand for that product in the marketplace, right? So rather than spending 5 to 7 years in development to try to perfect the product with focus groups and then coming out with a Pontiac Aztek, no offense to my friends at GM, and not ever hitting any of the production numbers. Our point is, let's go get a vehicle out there onto the road. Let's get it in beta, get it tested by consumers, and let's truly understand if there's demand for that vehicle in the marketplace. And if there is, we'll grow and scale it. And if there isn't, we'll go and move on to the next vehicle. And so I think it's that combination of the fact of a more flexible product development process and the fact that there's a different approach to really introducing vehicles. And then thirdly is because we have more people thinking about it and iterating on it in an open way. Because we have, for example, even after production starts, we have an open wiki, and then people can literally work on contributing based on feedback of the vehicle through owners and other things on making the next one for production even better than the last one, even during production runs. All right, so this is our, how many of you saw this video before for the first 3D printed car? Did anybody see this? Okay, one person. All right, we got.
I think I saw the Obama wrote it, right? I think I saw that.
Dan, that was the. And
What's that?
That was a Cobra.
yeah, no, that was the Cobra. Yes, he rode in our DARPA vehicle, which I didn't show. He did not officially take. He sat in it, but he rode in. Him and Biden rode in the Shelby because Oak Ridge, after they worked with us in 2014 on the Strati Challenge, which was initiated in a relationship with Oak Ridge in early 2014. And by September of that year, we printed it at IMTS in Chicago. After that, subsequently, they 3D printed an electric Cobra, and they launched it at the Detroit Auto Show in 2015.
Yeah, I think that's what 3D printed it, and then spent 4 weeks putting bond on it. 4 weeks bond.
Well, and they finished another significant amount of time making it look shiny, right? Yeah, very significant. But I wanted to highlight, this was really our transition from more traditional manufacturing methods. And by the way, the average kit car, and some people call the Rally Fighter a kit car, the average kit car takes about 2,000 hours to build, okay? When we got to really production of the Rally Fighter in 2010, we got it down to 400 hours, right? And that's for a kit car or for a DIY car, that's pretty astounding and pretty competitive. The traditional, when I mentioned the Ulsan factory that spits out 2 million vehicles a year, they come off the line every 45 seconds. So on average, they take about 16 hours, 17 hours to get assembled altogether. But that doesn't take into account the number of hours that get put into putting together subassembly like an engine, right? So like the engine comes there, the seats come there, all of that subassembly work that happens at other factories isn't taken into that time. So when we originally started with the Strati in 2014, it was taking around 45 hours. Well, originally, it was taking around 160 hours to print just the body. And then after 4 weeks, just between our first prototype that was done in-house to the one that was built in Chicago at McCormick Place, it went down to 44 hours. And so the print speed was roughly, and by the way, the print speed, you see it right here in the bottom, your bottom left, my bottom right. That's really the BAM. So the things that we're advancing in direct digital manufacturing and on the additive and the subtractive side is we're really working on 3 fundamental things. One, the tooling required to make these, right? These are basically big maker bots with big nozzles to go and layer by layer add carbon fiber reinforced plastic. 2, we're working on the materials, right? And so what's in the top right corner that you can see the hand, those are actually carbon fiber reinforced ABS plastic pellets that are like micro strands of carbon fiber into those. And those get dried and then heated to go be put on layer by layer. So we're working on compounding of some advanced polymers. So we've done everything from nylon, fiberglass, nanocellulose reinforced plastic. We've messed around with titanium. We've done some work in graphene. Graphene's great. It's really light and really strong, but it's expensive as hell. So that's not necessarily meeting our TCO, right? Time of being able to print, cost, and quality, right? We would get probably pretty decent time, really high quality, but just crazy amounts of cost that nobody could afford. So those are really the 3 areas and the third area is software, right? Rather than design for manufacturing, we have to focus on design for additive. And there's certain things there's a lot of opportunities to do really cool shapes and print really cool geometries with the tools that we make, but you have to have the software that can, one, convert the CAD file into a printable file, and then two, because after you print, the CAD, the piece that you print isn't going to match one-to-one to your CAD file, right? And so you can't just mill it from a finishing perspective. So you actually have to have scanning software to rescan and then to be able to program off of that to go and do the subtractive part. So all of those things we're working on with partners like on the material side with like Dow AXA, Henkel, Sabic, BASF, and on the software side with people like Siemens and some others. And then on the tooling side, we're working on potentially even 6-axis router printer combination to be able to do the additive and the subtractive in the same tool. So those are some really cool things that we're working on with like organizations like Cincinnati and Thermwood, and Wolf Robotics and some others. I think we haven't I don't think 3D Systems, for example, or Stratasys is just starting to play with really large-scale printing. I mean, this is the Ingersoll Rand and Oak Ridge National Lab just partnered. Our printer, the BAM, is a ballpark 20 by 8 by 12 scale 3D printer. They have created with Ingersoll Rand, they're working on that is 24 by 14 by 43. So they're really, Oak Ridge started printing houses last year. Chinese companies are doing the same in Dubai. So that's really one the areas of focus from a direct digital manufacturing perspective that we have. And then after the Strati, right, which was kind of a cool 2-seater, low-speed electric vehicle, in January of 15, at the Detroit Auto Show, we announced that we didn't just want to make toys, even though that vehicle that you see right here kind of does look like a little Beach Boys toy. But the point is that we wanted to move towards a highway-certified vehicle. So this was the LM3D that we introduced at the SEMA show in 2015 in November, after we issued a challenge in May of 15 to our community to develop a vehicle that could be 3D printed but move towards highway certification. So this, as you can see, still doesn't have doors, but the red is actually a finished part that's wrapped. The black is kind of raw 3D printed material, and instead of being a unibody, this actually is about 6 body panels on top of a rolling chassis that represents an i3 powertrain and an i3 chassis. So we kind of took an existing powertrain and chassis and put a body structure around it. So this was the first instantiation of this. It also doesn't have doors, which when it comes to making doors and crash testing, doors are really some of the hardest things to actually make. They're pretty complex. Most people don't think about it, but they're pretty complex to be able to engineer into a chassis and body structure. The journey also means that what we really want to focus on is to use platforms. So the upper left is really our Axion electric motor. So that's part of our powertrain. So in the future, we want to offer multiple powertrain options. Right now, we're focused, because of reduction of complexity, on electric motor drives and batteries. And then you want to have a skateboard or a platform that you can then build off of multiple body styles and be able to print that in the same facility, because we use direct digital tooling. So that's a little bit of our micro manufacturing and co-creation process. And then we'd use that, our community and our production facilities, to make vehicles, but we actually have partnered with Airbus to do this with them for drones. And we've also partnered with GE to do it for appliances. So in Louisville, Kentucky in 2014, we launched First Build with GE appliances. And then this October, at IMTS in Chicago, we announced the Lex collaboration with GE that's called Fuse. And they're actually going to do a microfactory in Chicago to go and roll out this rapid commercialization, rapid product development process and micro production across a number of the other GE divisions. So right now we're working with GE Digital Solutions to do non-destructive testing. And then in the future, there may be more potential tendencies on our fourth platform to go and do this, provide this as an outsourced service for other industrial companies. So the point around this is really to get the whole co-creation platform and the micro manufacturing and the direct digital manufacturing is to really shrink this complex traditional value chain that spans multiple channels, and to take development time from a vehicle concept to vehicle production ready from 5 to 7 years, which is the average time it takes traditional OEMs, to really less than 6 months, and to have a much more vertically integrated supply chain and partner value chain, but also a much more direct to consumer engagement rather than some of the distribution channels that the traditional OEMs go through on a small footprint. So each one of our microfactories actually is a development and engineering center, and each one has a different center of excellence, right? So Knoxville is focused on materials development and application. National Harbor is going to be focused, or DC, Maryland's going to be focused most likely on transportation systems and cybersecurity potentially. Phoenix is more on powertrain application and autonomy, and Berlin is also autonomy and software development and systems development, because in the future, and what we're doing with our self-driving vehicle shuttle that I'll show in a second, we're focused on not just selling a vehicle, but an entire system design around the vehicle. So the other point of this is that we want to be able to integrate the latest and greatest technology into the vehicle. So not just to have, outdated hardware in the vehicle, but similar to what Tesla's talking about, being able to each night make the vehicle smarter, right, with over-the-air software updates. We want to believe that because of our approach and our open-sourced environment, we can integrate the latest hardware. So a good example of this is Watson. In January at the Detroit Auto Show, IBM announced they want to put Watson in a vehicle. By March of this year, they worked with us to put Watson in the Ollie, and by June, we had Watson in the Ollie. And so now we're working on what that means, right? Cognitive intelligence. So if you have a driverless vehicle that is a multi-passenger urban shuttle, right? You don't have an operator on board. How do you potentially have an interaction between the vehicle and the user? The point is, Watson, with its cognitive intelligence and interaction ability, that's what we want to be able to do. And so I want to show a quick video that shows that. It's a little long, but bear with me. I think it'll do a good job explaining what we're talking about.
Hello, my name is Ollie, and I'm making history.
This is a huge day in automotive history. Not only is it the day where Ford Motor Company was incorporated June 16th, 1903, but also it's the day where we got people comfortable with the idea of riding around in a completely self-driving vehicle. I'm Jay Rogers, and I'm the CEO and co-founder of Local Motors.
I am the first cognitively enabled vehicle. I seat 12 passengers. And you can ask me anything.
Ollie, why don't you say hello?
Hi everyone, my name is Ollie. I'm a self-driving vehicle powered by IBM Watson technology. I can help people get around National Harbor.
Ollie, I'm hungry. Where can I get some food?
National Harbor has some great seafood. Would you like that?
That sounds great. What's good?
Well then, try the Crab Cake Cafe.
All right, I'll go there for dinner.
Okay, but don't forget your umbrella. There is a severe thunderstorm warning tonight.
The sensor set on this vehicle allows us to be able to feed data to Watson and feed data back to Ollie to make life more enjoyable. Thanks, Ollie.
By the way, I like your bow tie. I'm what's next in automotive innovation. I come from Jay and the engineers at Local Motors.
Local Motors is a technology company that it's here to revolutionize a 120-year history of the way that vehicles are made.
I still remember the first time someone told me about Local Motors and they said, we have a 3D printed car. And then I saw their vision in projects like Ollie.
You're going to see this shift. You're going to see the vehicles become more highly automated, ultimately autonomous. You're going to see vehicles become cognitive. And so Watson IoT Auto Lab is very much around the future of that cognitive experience.
Not all of the information, not all of the capability for the vehicle is now going to be on vehicle, be enhanced by things in the cloud.
And the best part, this is just a start. I'm about to go global.
By the end of the year, you'll see Ollie in Copenhagen, and you'll see him in Las Vegas, you'll see him in Miami-Dade County, and several other places around the world.
I can create a platform for all developers to engage and shape the future of self-driving vehicles.
We co-create. It's our people and their people together, side by side, creating the future of cognitive mobility.
It was very exciting to us when IBM approached us and said, could we partner with you in putting Watson IoT into one of your vehicle sets, and could we do it quickly?
And you have to be able to ask questions. Just like my passenger asks me, are we there yet? You can ask Ollie these same questions.
The world of IoT is moving at lightning speed. The only way to stay ahead of that game and to be a player in that game is to be able to innovate as quickly as possible, be able to assemble and deploy solutions as quickly as possible, and that's what Local Motors is trying to do, and that's definitely what IBM Watson IoT is doing.
We started on this project 3 months ago, and 3 months ago doesn't mean we made a prototype. We sold our first 10 Ollies today.
That's a dream, and it's possible because of all this technology.
Well, so long for now. My name is Ollie. It was sure nice to meet you.
So the funniest part about that was this was during our grand opening week that they taped this in June in National Harbor, and I'm a gearhead a little bit. I'm a rambling wreck from Georgia Tech and one hell of an engineer. I couldn't help myself, but so I remember the days when my granddad and I would go and work on cars, and you slide underneath, change your oil, fix whatever, brake pads, whatever you had to do, and you got down and dirty and nasty, and you had to take a shower after you worked on your car for an hour, right? When that week you saw a bunch of people sitting inside and it was everybody on the computer, well, that's what happened, right? Because we have a drive-by-wire system, so drive-by-wire steering, drive-by-wire braking. So I had and then we have battery electric powered vehicle, so we have BMS. So I literally had my electrical engineer, my battery software engineer, and some of my steering fluid guys, all sitting there trying to calibrate the system. Nobody had a wrench out. Nobody had oil out. Nobody was on their knees. They were sitting there and coding away. And that's the future of what we're doing is, right, everything is now code. And that's the additional complexity of a system in that already traditional complex 20,000 component system. If you add 20 million lines of code, that gets much more complex. So with that, I'll break. I think right at the very end, I'll show you another video just to kind of bring it all together that talks about what the consumer experience of Ollie could be in the future, and also what the consumer experience of somebody who wants to buy a 3D printed car could be in the future. But before I do that, I want to just open the floor for questions and anything else. So thank you.
So let's open it up. Please use the little vertical button and the mic will turn red. One over here.
What are the implications for deglobalization with this approach? Suddenly the factory's by your house. You can make it all there. Just think even more worldwide when you think about it. So rising economies going through the old model, say like Indonesia, which would like to jump in on China's tail, probably can't do it anymore. Have you thought about that?
Yeah, I think we completely understand that with this new technology on both the manufacturing, direct digital side, as well as the autonomous side, there's potential to displace jobs, right? There's a potential to displace job, there's a potential to add jobs. As I said, we're focused on probably 1,000 to 3,000 units a year at each microfactory, right? And a footprint that's pretty small. We've certainly been approached by organizations in certain countries that said, why don't we just make it 10x bigger and just produce 30,000 cars? I think that could happen. That's not our focus, right? We think that down the line, maybe there's a demand for 1 million Ollies in the world, but we're not interested in doing that ourselves because of the capital intensiveness that you have to put into that business to make it make sense, right? Because for low volume niche manufacturing, additive makes a ton of sense, right? Because you create a price premium. But if you now then want to make 100,000 of that, traditional manufacturing, mass manufacturing, just economies of scale, just make more sense that you invest in the stamping or the mold making or the die making to produce that and then just knock it out and you get it back over time because your variable cost decreases to such a point. So I think we don't believe mass manufacturing is going away anytime soon, but what this enables, it enables local economies of a certain scale to potentially create locally relevant vehicles that the bigger OEMs just don't have an appetite to do because it doesn't make economic sense. So I give you a good example, like Puerto Rico, right? Old San Juan has narrow streets. They've approached us and said, can you make a purpose-built waste management vehicle? Because they want to be able to go down the narrow streets of San Juan. Alberta, Canada, right? The oil sand country is like a huge consumer of F-350s from Ford, but they literally like die in 2 years because all the oil sands gets into the engines, and they've approached Ford and said, can you just not make us one that has the proper protections underneath the vehicle? And Ford's like, yeah, if you can work with a rebuilder, we'll actually create a vehicle that you can work with, but it doesn't make sense for us to invest in the tooling for your 1,000 units, right? So I think there's niche applications that make sense to make in a micro manufacturing facility to meet local requirements, but for the foreseeable future, mass manufacturing isn't going away. So I think there's both, right? We've talked about reshoring or deglobalization, and obviously this incoming administration has talked about that a lot. We believe we can create local advanced manufacturing economies that create jobs across a broad spectrum. Like I have jobs that are skilled trade, low skilled trade, high skilled trade, and I have PhDs and senior engineers working all in the same facility, and then I have administrative support and marketing support all within one factory, and it creates around 150 jobs. So I think for us it's a balance of a number of skills, but we're not trying to replace mass manufacturing from our perspective. Yes, ma'am?
So I was wondering, it seems that you have devised a system to be quite flexible and adjust to the demands and needs as you described. But what I notice, societies are kind of always behind in terms of the regulation. So, I mean, it must be really hard to work with technology like you presented, because it takes a long time to have the regulatory environment to allow these things to succeed or not.
Right, great point. So I actually, right before I got here, I was with some people in Crystal City as we were planning to introduce autonomous vehicle in Crystal City by the year 2020, right? What are the policies and burdens and regulatory hurdles we would have to overcome, along with some other challenges. NHTSA, for example, speaking of autonomous, US DOT issued guidance and policy in mid-September that the public comment period was just about, they kind of created a framework. But then still there's a model state policy to be addressed, and some states have taken a leadership position, like Nevada and California and Michigan, but the California model is completely different than the Michigan model. So I think what the right framework is, I don't know. I know that we want a framework that obviously creates a safe environment for our products, to operate in, but also one that doesn't put a regulatory burden on us to advance technology. So I think in the autonomous space, that's going to be heavily dependent on local cities and municipalities to go work together with organizations like ourselves to create true public and private partnerships as we've deployed this technology. On some other areas like highway certification for our vehicles, because we're doing completely different materials and different production methodologies than the traditional OEMs, our objective at the beginning is, I think, to meet the current standard, right, from FMVSS perspective, rather than trying to get exemptions or trying to change regulation. Because one, I think we have to prove to consumers that our vehicles are safe. And so if you adhere to current standards, then that, I think, gives a good parameter of safety. The other thing is, once you have proved that your vehicles are safe, then you can potentially work with the regulators to adjust, because you now have created a different way of making things that the traditional OEMs haven't. And so now you need to say, well, let's listen to how this could be done differently in the future and what may make sense. So I think it's a constant collaboration, but I think there's also this notion that for, especially on the highly automated side, that, and this has already been proven in California, right? They came out with regulation in 2012, and last year or 2 years ago, they realized, oh wow, technology is moving faster, and so now we have to adjust it again. So you have to, I think, work with policymakers, whether that's organizations like Virginia Tech influencing what you're doing down in Blacksburg at the state and federal level, to go and say, how do we create flexible environments to be able to deploy this technology safely? So yeah, it's not easy. There's not a cookie cutter approach or solution.
We will take one more.
We have two.
Okay.
Go ahead.
Go ahead.
So thanks for the talk. I was wondering if you could say, what's the sweet spot for a car that is between mass manufactured and totally customized cars? I mean, how much do you think people are willing to pay a little bit more to have a car that they can really customize beyond what you can do now?
Good setup. I think the video will address some of that. But what, I think people say, oh, and this, just remember that this is a commercial, so it's not necessarily one-to-one what we're actually doing, but it describes a concept. I think what we talk about is configurability, right? Because the notion that you come into our facility, design your vehicle, and then walk out with it after we print it is, even for us, a challenge to do from a logistics, supply chain, complexity perspective, but also from a regulatory perspective. There may be a future where, down the line, you have a big enough garage and you have your 3D printer in there, and under today's DIY rules, right, do-it-yourself rules, which is how we got Rally Fighter to be street legal, because people actually bought it and then flew to our facility and contributed 51% of the build to the vehicle. That's how it became street legal. You could technically design your own vehicle and print it and assemble it and operate it on the road, right? Because we could, for example, give you the file and you could do that and slap your own tag on it and insure it, right? I think that's still more of a hobby-ish kind of thing. From our perspective, you come into our facility and we give you a configurable vehicle. Like, you can pick from a certain powertrain, a certain skateboard chassis kind of thing, a certain set of body panels that meet the safety regulatory standards that we have to adhere to as part of FMVSS or whatever the future may be. And then you create that. You asked for the sweet spot, right? I think if you create a value that's to local requirements, whether that's a B2B vehicle, like a self-driving electric shuttle, or it's a B2C vehicle, like a potential neighborhood electric vehicle, right? So I'll give you a good example. We think that we have a potential opportunity to displace golf carts in low-speed gated communities or amusement parks or college campuses, right? And because our cost curve is coming down significantly from a materials perspective and a powertrain perspective, and our production time is increasing. So if you go work with communities like the Villages in Florida, and you can say, hey, you can have a customized 2-seater or 4-seater to drive under 25 miles an hour around your community versus having a customized club car, which isn't really that customizable. I think there's a premium in it. I don't know how big that premium is yet, but we think there's a premium that people will pay for. But at the end of the day, it's a niche vehicle that you have to target a specific local requirement. And I think if you can do that and you can get that feeling of, well, this is really a Detroit company or this is a DC company, you get also a little bit of that hometown flavor. I can't tell you the exact sweet spot, but I think there is a sweet spot that you can adhere to as a niche low-volume manufacturer with configurable vehicles and probably not fully customizable vehicles.
Okay. Really short. And then
Yeah.
Okay.
No.
You still got
Yeah.
a couple minutes.
Yeah.
Okay, it's two questions, but they're two fast questions. One is, how big is a microfactory that's putting out 3,000 units? And the second question is, so if you guys are like the small niche player, what is how would it work if like the Ollie really does take off and somebody wants to mass produce it, then you would have somebody else mass produce it?
We would partner with a contract manufacturer or a larger OEM that has some of the infrastructure investments or is willing to make them. And provide the capital assets to get to scale beyond what we're comfortable with. And the microfactory question is around 50,000 square feet. All right, so last video of the day. This is also a little bit for comedic relief. The person on your right is James Corden, the host of The Late Late Show. So here you go.
Are you serious? Can I have an ejector seat? Let's do it. I don't want to eject, but if my dad is being annoying, gone. I've come down to Tennessee because I want to visit every single nook and cranny of this strange and beautiful country. While I'm here, I'm going to get a 3D car printed to help me with all of my Tennessean needs. Is that a thing? I'm just waiting here. There should be someone called Ollie coming to pick me up. Ollie?
Hello, James.
Who's that?
It's me, Ollie. Please have a seat.
Right. Where's the driver?
I'm the world's first cognitive, self-driving shuttle. And I'm electric. I'm the future of travel.
Is this your only voice? Can you do any other voices? Can you do a Tennessee accent?
Hey, y'all. Who wants grits?
I mean, honestly, I don't always trust my driving. Why would I trust a computer?
Because I don't drink, text, or get tired.
So how do you flirt with other buses if you don't text?
Ha, ha, ha.
Was that your laugh? Thanks so much, Ollie. Thank you. Hello.
Hi.
How are you? I'm James.
James, I'm Jay.
Nice to see you. Hello.
Brittany.
Are you real or are you robots?
How would you know the difference?
I'll take your word for it. Let's get in there. Come on. Totally a robot. Right, Jay, Brittany, who are you and what do you do here? And bear in mind that I will believe every word you say.
I run Local Motors, a technology company that designs and builds vehicles tailor-made to their location. We 3D print them, and then we can put in driverless technology or technology that talks with you when you're in the vehicle. The Ollie's almost fully 3D printed. The car that we're making for you is fully 3D printed.
How will I be able to customize the vehicle?
You come up with it and we will make it happen.
In the future, we could really imagine that the rental car company becomes the car maker themselves. You can get into a vehicle that's bespoke for the experience that you want to have while you're traveling. We think this method is the future of the travel industry.
So can we go now and design my car that I'm going to see Tennessee with? I've got some ideas. I'm just saying, prepare to be blown away.
Greg here's going to help you out.
Hi, Greg. I'm James.
Yeah, good,
How are
James.
you?
How you doing?
So I can put anything I want on this car.
Yep.
I'd like no roof. I want it convertible so I can feel the southern wind in my hair. Cruise around Tennessee, top down. What I'd love is the ability for it to become a hovercraft. Instead of a horn, it just goes, the gear shift. I'd like it to be a mold of my hand, so I'm capable at all times of holding my own hand.
Okay.
Yeah?
Yeah.
Feel it. How does that feel?
Awkward.
So this right here is the 3D printing machine that your car is actually being printed on.
Wow. So can this 3D print anything?
What do you have in mind?
Like a bathtub,
Yes?
a watch,
Yes?
a 3D printed father who says, I'm proud of the choices you've made. Do you think this is how all cars will be made one day?
I think that's the direction everybody is heading. I think we're just ahead of the curve.
Well, this is you. Where's the curve?
There.
There. That's not way past. You're a foot ahead of the curve.
You're
not
right.
actually that impressive when you look at it like that.
I said, I want all vehicles to be different. 3D printing offered us a way to make a custom vehicle for a traveler that suits the needs of where they're going anywhere in the world. What do you think?
I don't know what to say, Jay, other than you're welcome. I mean, this feels great. I mean, oh, and look at that. There it is.
Look at that.
Jay, let's take this bad boy for a spin.
Hold it, James. That rental isn't free.
Oh, yeah, you're absolutely right. Can I give you my Chase Sapphire Reserve?
You know I don't have hands, right? Just pay online.
Is that okay?
Affirmative.
I'll see you around Tennessee, Ollie.
Why do the pretty ones always leave?
Oh no, I forgot a radio. I thought that was standard.
Thank you. Before I release you to the reception, we have a small parting gift.
Thank you very much.
It's in the. It's not in yellow and gold, unfortunately.
It's okay. Orange is a good color.
Orange, yeah. So thank you again. This was a fantastic talk. It was really cool.
Appreciate it.
Please join us at the reception for a few more minutes of conversation. Hopefully, David can stick around. All right. Thank you very much.